I'm Anil Kumar. Welcome to my series on calculus. In this video, I'm sharing with you a test paper based on derivatives and optimization. There are 7 questions here. All of them have been taken from previous test papers. We'll first go through these questions and then answer them one by one. You should feel free to pause the video anytime, answer the questions, and then look into my suggestions. Question number 1 is, find the critical numbers and find the absolute maximum and absolute minimum values of f of x equals to x squared minus 1 over x plus 2, where x belongs to minus 1 to 3. Question 2. Suppose the population in thousands of certain species of insects after t months is described by the function p of t equals to 4t plus 100t over t squared plus 400 plus 500. Determine the maximum population in the first 3 months. Question 3. The cost price of a Saturn is $13,000. When the dealer sells each car for $25,000, he sells 21 cars per month. For each car reduction of 1,000 in the selling price, dealer sells 3 more cars each month. Determine the selling price of a car for maximum monthly profit. Question 4. A cable television company is laying cables in an area with underground utilities. 2 subdivisions are located on the opposite side of a 200-meter wide river. The company has to connect points P and Q with cable, where P is on the south bank and Q is on the north bank 2,000 meters east of P. It cost $8 per meter to lay cable underground and $8.10 per meter to lay cable underwater. What is the least expensive way to lay cable, and what is the minimum cost? Right. So these are the first 4 questions. Now let's see the question number 5. A rectangle is inscribed in a semicircle of radius 8 meters. Find dimensions of the rectangle that will maximize the area of the rectangle. Question 6. Find the closest point to the graph of y equals to 6 minus x squared from P03. Question 7. An object starts at rest and moves along a horizontal trail. Its position s in meters after t seconds is given by the function 3t cubed minus 9t squared plus 24t plus 5, where t is greater than or equal to 0. When is the object at rest? Determine the velocity after 2 seconds. Is the object moving towards or away from the starting point at t equals to 0? At t equals to 2, justify your answer. So you can pause and answer some of these questions. We'll begin with the very first one. Question number 1 is, find the critical numbers and find the absolute maximum and absolute minimum values of f of x equals to x squared minus 1 divided by x plus 2, where x belongs to minus 1 to 3, both included. So when we have a closed boundary, we'll definitely have absolute maximum and minimum value, which could be on the boundary or within inside when we have a critical number. So we are given the function f of x, which is equal to x squared minus 1 over x plus 2, where x belongs to minus 1 to 3. So as you can see, it is continuous in given domain. Right. So therefore, we'll have absolute maximum and minimum values, correct? So we know the boundary conditions. Let's find the derivative and find the critical numbers. So the derivative for the given function can be written as, applying the quotient rule, we get x plus 2 whole square. derivative of numerator is 2x times x plus 2 minus derivative of denominator is 1 times numerator, which is x squared minus 1, right? That is 2x squared plus 4x minus x squared plus 1 over x plus 2 whole square. 2x squared minus x squared is x squared. Then we have plus 4x plus 1 over x plus 2 whole square. Now denominator will be 0 at x equals to minus 2, but that is not in our domain, right? So let's look into the numerator now. So when is the derivative equal to 0? So for that, we'll actually equate x squared plus 4x plus 1 equals to 0. So that gives you x should be equal to minus 4 plus minus square root of 4 square minus 4 times 1 over 2 times 1, and that is minus 4 plus minus 16 minus 4 is square root of 12 over 2. So this is 4 times 3, 2 square root 2. You write this as minus 2 plus minus. So 2 cancel, square root 3, right? So that becomes your critical number. Okay. Let's find a decimal equivalent. It'll be easier for us. So we have minus 2 minus square root of 3, which is in decimals equals to minus 3.73. So we have two values here. One of them is minus 3.73. The other one is minus 2 plus square root 3, which in decimals is minus 0.26, we can say 8. So these are the critical numbers. However, our domain is right there. So from this, we can say that the critical number is only 1, right? So we'll write down the critical number first. So critical number is minus 2 plus square root 3, that's the exact value, which is equal to minus 0.268 to 3 significant places, right? This is to 3 significant figures. Okay. Now, let's find the absolute maximum minimum value. So that could be at minus 1. So let's calculate this value at minus 1. So at minus 1, we'll get this as, when I put plus or minus 1, we'll get 0, right? Let's calculate at 3. So f of 3 is what? Which is 9 minus 1 over 3 plus 2, right? So 8 over 5, correct? So 8 over 5, 1.36, right? And now we'll also calculate the value at a critical number, which is minus 0.268, right? So which gives us minus 0.268 whole square minus 1 over minus 0.268 plus 2, correct? So let's find this answer. So which is 0.268 whole square minus 1 divided by, within bracket, 2 minus 0.268, right? So approximately this is equal to minus 0.53, correct? So we have 3 values here. So from here we can write down what is the absolute maximum value and what is the absolute minimum value, correct? So the answer here is absolute minimum. So we have to write find the critical numbers and find the absolute minimum and maximum values, right? So we have to write the values. Absolute minimum value is minus 0.53, and absolute maximum value is 8 over 5, which is 1.6. Correct? So, so that is how we are going to write our solution. Is that clear to you, right? Let's move on and take up the second question. Question number 2. Suppose the population in thousands of certain species of insects after t months is described by the function. So let's write down the function. P of t equals to 4t plus 100t over t square plus 400 plus 500. Okay. Determine the maximum population in the first 3 months. So first 3 months means t is from 0 to 3, right? So that is your first 3 months, right? So starting 1, 2, or 3, okay? Those are the values which it could have. Now, what we can do here is sorry, it should be 1 to 3. So let's say it starts in January. So January is the first month, right? So first 3 months. Okay. Let's find the derivative so that we know what critical numbers are. So the derivative of this function is 4 plus derivative of this part, which is t square plus 400 whole square. Derivative of 100t is 100, so it is 100 times t square plus 400 minus derivative of denominator is 2t times 100t. Correct. Now within this interval, let us see, do we have a critical number here? So let's simplify. So we have 4 plus, we have 100t square plus 400, 100, okay, minus 200 t square over t square, sorry, over t square plus 400 whole square, correct? Right. So let's write it here. So that gives us the derivative as equal to 4 plus. Now 100t square minus 200t square is minus 100t square plus 400, 100. Okay. Divided by t square plus 400 whole square. So you could actually see from here itself, it is 4 plus something, and we want to make this as 0. You will notice that this value here is going to be negative only after t becomes greater than 20, right? So for our domain, for t between 1 to 3, we can see that p dash t is actually greater than 0, right? It is not even close to 0, right? This portion here will be 0 if t equals to 20. So even then it will be 4 here, correct? So 4 plus something. So our derivative is positive in the domain of our interest. So in this closed interval, we do not have any critical number. So no critical number. Now, to get the maximum, we can actually just work with our extreme values, which are 1 and 3. So let's find the value of the function as t equals to 1 and also when t is equals to 3, right? So that should give us the answer. So if p of 1 will be 4 plus substituting 1 here, we get 100 over 401 plus 500. And substituting 3, we get 4 times 3 is 12 plus 300 over 3 square is 9, so that is 409 plus 500. So let's calculate these values. So the first one is 4 plus, let's write within brackets, 100 divided by 401 plus 500. And that gives us a value equal to 504, right? And it is in thousands, right? It says 0.249. And this value here is 12 plus, within brackets, 300 divided by 409 plus 500. And this is 512.733. We can say 5, right? So definitely at the end of third month, it is maximum. It says population is in thousands, and therefore our answer will be what? So in thousands, we'll write this much, right? So many thousands, correct? So our answer is maximum population will be 512, since it is in thousands, 733. Clear? So that is how we are going to answer this question. Now let's take question number 3. Question number 3. The cost price of a Saturn is $13,000. When the dealer sells each car for $25,000, he sells 21 cars per month. For each car reduction of $1,000 in selling price, dealer sells 3 more cars each month. Determine the selling price of a car for a maximum monthly profit. So as you know, profit is basically equal to revenue minus cost, correct? So that's the basic formula. Revenue is cost times the number of items. So let's write down the profit function. So when he's selling the cars for $25,000, 21 cars are being sold. Now on the reduction, 3 more cars, reduction by 1,000. So for every 1,000, 3 more cars, correct? So we can say that the revenue is product of number of cars sold into the cost, right? So the number of cars is 21 plus 3 times X, where X is number of thousands reduced, right? So the cost, rather the selling price, will become 25,000 minus 1000X, right? So many thousands reduced. The cost will be on the number of items sold, correct? So each is 13,000. So 13,000 times 21 plus 3x. So that becomes the profit function for us. Now we need to simplify this expression and find the derivative. So let's multiply. So we should use calculator for this question. So we have 21 times 25,000. That gives us 5,000 minus 21,000 x plus 3 times, which is 75,000 x minus 3,000 x square, right? And then we have 21 times 13 in thousands, 273 minus 273,000 minus 39x, 39,000x, right? So that's what we get. Now let's try to combine the like terms. The x squared term here is only 1. This gets multiplied to give you minus 3,000x squared. Okay. X terms, let's combine these. We have 75,000 is plus, from which we'll take away 21,000 and then we'll take away 39,000. And what we get is 15,000. So we get plus 15,000x as far as the numbers are concerned, we have 525,000 minus 273,000, 252,000. So we get plus 252,000. So that is our quadratic equation. Let's find the derivative of this function with respect to x, right? So derivative with respect to x will be minus 6,000 x. Here we get plus 15,000. That becomes the derivative. And let's find the critical number equating this to 0. So if we equate this to 0, we get the value of x as equal to 15,000 divided by 6. So which is 6,000, sorry. Okay, so 15 divided by 6, which gives you 2.5, right? In decimals, which is 2.5. So the x value is 2.5, for which we get a critical number. Now, at this critical number, let's find the profit. Determine the selling price of the car for the maximum profit. So we have to find the selling price. Now, in our expression, selling price is this. Correct? So that is the selling price. Now, clearly, the quadratic function which you have here, the quadratic function is a parabola. So this quadratic function is a parabola which is opening downwards. So the critical number is a maximum, right? So we know critical number is a maximum. Correct? So that is how we are proving that this critical number is a maximum, right? So now we'll find the selling price by placing x as 2.5. So the selling price will be 25,000 minus 1,000 times 2.5. Correct? So let's do it. So we have 25,000 minus 2,500, which is 22,500. Correct? So that becomes the selling price. And therefore, the maximum profit monthly, this is the maximum monthly profit. So the best price to sell is, so selling price of dollars, 22,500 will give maximum monthly profit. Is that clear to you, right? So, okay, we are reducing by thousands, but you could always reduce by hundreds, 500s also, right? So fraction of thousands is possible. Let's look into question number 4. A cable television company is laying cable in an area with underground utilities. 2 subdivisions are located on the opposite sides of a 300-meter wide river. The company has to connect points P and Q with cable, where P is on the south bank. So let's think like this. We have a river here. P is on the south bank and Q with cable, where P is on the south bank and Q is on the north bank, 200 meters east of P, right? So let's say we have P here. So 2,000 meters east of P. So Q is somewhere here, where the distance is 2,000. Is that clear, right? And we know it is 200 meters wide river. So we know this distance also, correct? It costs $8 per meter to lay underground cable and $10 per meter to lay cable underwater. What is the least expensive way to lay the cable? Okay, so what we could do here is that we could lay the cable underwater for some distance and then run it underground. So that could be one way of doing it. Now, if we do that, let us assume that it is x units or x meters down from P. Then this distance will be 2,000 minus x, right? Which is underground. Now, underwater distance will be, let's say, we'll call this point as R. So we have to find what PR is, right? So here we have seen that X could be anywhere from 0 to 2000, correct? So the underwater distance P to R will basically be equal to X squared plus 200 square root, since this is right angle, correct? So that is that distance. Now, as far as the cost is concerned, we can now write down the cost with distance in terms of X will be equal to cost underwater is $10 per meter, so it will be 10 times the distance, which is square root of X square plus 200 square. Let me write four zeros. Okay, plus this cost, which is 8 times 2000 minus X. Correct? So that becomes our cost function. Now, to find the critical number, we'll actually find the derivative of this expression. So derivative will be, this is a square root function, right? So that is half of this to the power of minus half. That means we get square root of X squared plus 400 times the derivative of this function, right, which is 2 times X, right, inside function. Okay, so half of this to the power of minus half, we get this, and here the derivative will be minus 8, right? So 2000 times this, we get minus 8. So that becomes our critical number. Equating this to 0, we can find the value of X. So that is 5. 5 times 2 is 10. Okay, so this 2 and 2 cancel. Let's do it like this. So what we get here is 10x equals to 8 times square root of x squared plus 400, right? Okay, let's take it on the right side to solve it further. So we can square both sides. So we get 100x squared equals to, squaring we get 8 squared 64 times x squared plus 400. So we can take x squared terms on this side. So we get 100x squared minus 64x squared equals to 64 times 400. So let's use calculator and find the value of x. So we get 100 minus 64, which is 36. So we can say x squared is equal to 64 times 400 over 36. Correct? So we'll divide this by 36. So we have 64 times 400 divided by 36 equals to, in decimals, let's take the value in decimals, which is 71111.1. So x is square root of this, right? So square root of our answer gives us a value which is approximately equals to 266.6 Regri, right? So that becomes the value of x in our case, right? So this is approximately equal to 266 point, you can say 7 meters from this point, correct? So what is the least expensive way to lay the cable, and what is the minimum cost? So let's take it on a fresh page and find both, right? So what we figured out that x is a value between 0 and 2000. The cost function for us was equal to 10 times square root of x squared plus 400, right? We're taking the values from our previous equations, right? Plus 8 times 2000 minus x, right? So we got a critical number for x equals to 266.6 recurring, right? That is what we got. So let's find the cost for all these values, right? So we could have C0. So substituting 0 here, we can calculate the cost. How much do you get? So we get 10 times square root of 400 plus 8 times 2000, right? So that is, if we go straight, we got 18,000 as the cost. Let's also find the cost when x is 2000. So if x is 2000, this term is 0, and let's find the cost here. It will be 10 times square root of 2000 square plus 400, which is equal to 20099.75. And let's use our critical number, which is 266.6. So cost for 266. Let's say 67, right? Let's figure out this cost. That is 10 within square root. It is 266.67 square plus 400 plus 8 within brackets 2000 minus 266.67, and that is equal to 170,200. Correct? So 170,200 is much lesser than 18,000, so that is the minimum cost, right? So what is the least expensive way to lay the cable, and what is the minimum cost? So the least expensive way, getting back to our diagram, which is kind of like this, is basically you have to run the cable from P to somewhere here, and then like this, where the point is 266.67 meters from opposite to P, right? So that you could reach Q. So we get our answer as underwater it runs to R, where R is 266.7 meters from opposite end of P, right? And the minimum cost is in dollars 170,200, right? So that is how we could actually solve this question. I hope it helps. Question number 5. A rectangle is inscribed in a semicircle of radius 8 meters. Find the dimensions of the rectangle that will maximize the area of the rectangle. So let this be the semicircle. And we are having a rectangle within this. Okay. Now, let us say that is the rectangle. So we'll take advantage of the symmetry of semicircles. So let's draw an axis kind of midway like this, right? Now any point here on a semicircle with a radius of 8, right? So this we know is 8. On a semicircle, the point will be what? It is defined by x square plus y square equals to 8 square, correct? Of course, the value of y is positive, right? It's greater than equal to 0. It is less than 8 also, and it is y is, I should have written that y is between 0 to 8, right? So that is the maximum value, 0 to 8. Now in this particular case, let the dimensions be 2x so we have x here and x here. Let this point be y, or the given point be xy. That makes the rectangle with maximum area. So if we maximize even half the area, right, we can say that the rectangle will have maximum area, correct? So let's concentrate on this particular area where x and y are related with this equation. Area is in this case equal to xy, correct? Now we could rearrange and write one in terms of the other. So we know we could write y as equal to square root of 8 square minus x square. So area as a function of x can be written as x times square root of 8 square minus x square. You see that? So now we have a function of area in terms of x, where x is half the width of a rectangle, right? Now, which is as good as writing x times 64 minus x squared to the power of half. Let's find the derivative of this function to get the critical number. So we'll apply the product rule. So derivative of x is 1, so we get 64 minus x squared square root plus x times the derivative of this function. So x times derivative of this function will be 1 over 2 square root of 64 minus x squared times the derivative of inside function, which is minus 2x. We have to equate this to 0, right? So we have to equate this to 0. Equating this to 0 will give us the critical number. So basically this, let's simplify this a bit. We can cancel these 2's. Taking this on the right side, we get square root of 64 minus x squared equals to x squared over square root of 64 minus x squared, right? Now cross multiply, so we get 64 minus x squared equals to x squared. Taking this x squared, we get 64 equals to 2x squared. So we can now find the value of x from here. So we get x squared equals to 64 over 2, which is 32. So x is square root of 32. All the dimensions will be positive. Perfect. So x is 32 square root, which could be written as 8 times 16 times 4 square root 2. So x is 4 square root 2. We can now find the value of y also. Y is equal to square root of 64 minus x squared. X squared is 32. So y is also square root of 32, which is equals to 4 square root 2. Correct? So we get x and y value. So now we can write down what is the maximum area, right? So for maximum area, the critical number is x is 4 square root 2 and y is also 4 square root 2. However, the dimension here is this, right? 2x. Is that okay? Yeah. Now anyway, what we could also do here is to justify that this x gives you the maximum area. So the x which we have taken is actually within the boundary of 0 to 8, right? So it is between 0 to 8. So let's calculate area when x is 0. So when x is 0, in that case area is 0. When x is 8, in that case again area will be 0, right? So because this is our function, correct? X times 8 square minus x square. So we need to calculate area when this value of x is 4 square root 2. So let's calculate this value of area. And this is, remember, this is half the area, right? So this area is not full area. This is half the area. We are doing symmetry, right? This is half the area. So if half area is maximum, full area will also be maximum, correct? So let's calculate this value. So we can just multiply square root 32 times square root 32. So we'll get this as 32. Does it make sense? Right? So that is half the area. So now let's write down our answer. The answer says, find the dimensions of the rectangle that will maximize the area of the rectangle. So that when small x, I mean half of x is this much, so the dimensions will be 2 times this value, which is 8 square root 2. That becomes the width of this in meters by 4 square root 2, right? So that becomes the dimensions. So that is the dimension of rectangle. For maximum area. Is that clear to you, right? We worked on half the rectangle. Do you see that? So when we're talking about the full rectangle, you should not forget to write 2 times x. That is kind of critical. Is that clear to you? Let's move on and take question number 6 now. Question number 6 is, find the closest point on the graph of y equals to 6 minus a squared from P 0, 3. So let's try to understand the situation. So this is a parabola which opens downwards. So let's say this is the parabola we're talking about, right? Let's make the axis. So this point will be 6 and square root of 6 minus on these points. We have a point P which is right there where the y value is 3. Now the question here is to find closest point on this graph. So let us say that we have a point here which is closest. Let's call this point as R. So let R be a point on curve closest to P, right? In that case, the coordinates of R will be what? If I take x values a, then the y value will be 6 minus a square, correct? Right. Now, we also understand that if I draw a tangent, then these two should be perpendicular. It should be normal to the tangent for closest point, right? So let's find slope at R. So we have the function y equals to 6 minus x squared. So dy dx, the derivative, will be minus 2x. So the derivative dy dx at x equals to a will be minus 2a. So this is the slope of tangent. So therefore, slope of normal, let's call this as m perpendicular, will be negative reciprocal of 1 over 2a, correct? Reciprocal of this. So we know that this slope P to R, so we can write m slope from P to R is basically equals to 1 over 2a, right? Now we know that the coordinates of point P are 0, 3 and coordinates of point R are a 6 minus a square. Now we can also find the slope using y2 minus y1 over x2 minus x1, right? So that gives us a slope which is 6 minus a square minus y1, which is 3, divided by a minus 0. And this slope should be equal to 1 over 2a, right? So from our equation 1, right, we can say that this slope should be 1 over 2a, right? So that means this a and a will cancel. We can just cross multiply. So we get 1 equals to Now this is 6 minus 3. Let's simplify. So let's say half. A and A will cancel. 6 minus 3 is 3, right? So we get 3 minus A square. Or we'll bring A square on this side. So A square equals to 3 minus half, which is 5 over 2, right? So that is the value of A, which is plus minus square root of 5 over 2. Clear? So A square is 5 over 2. A is plus minus square root of 5 over 2. So we have 2 points, and from symmetry you can make out that there has to be 2 points. So these are the 2 points which will be closest to P, where the x values are minus square root 5 over 2 and plus square root 5 over 2, or 2.5 you can say, right? So these are the x values. So the value of x is plus minus square root of, you can write 2.5, right? So which is plus minus square root of 2.5. The y value will be 6 minus square of this, right? Plus minus square root of 2.5 whole square, which is 6 minus 2.5 or 3.5, correct? And therefore the point R will be, you can write this as minus square root 2.5, 3.5, and the other one on the other side will be square root 2.5 positive value, y value being 3.5. Is that clear to you, right? So that becomes the point which is closest to P, and this point is on the parabola given by y equals to 6 minus x squared. Perfect. Now here is the last question, question number 7. An object starts at rest and moves along a horizontal trail. Its position, s in meters, after t seconds is given by the function 3t cubed minus 9t squared plus 24t plus 5, where t is greater than or equal to 0. When is the object at rest? Determine the velocity after 2 seconds. Is the object moving towards or away from the starting point at t equals to 2? Justify your answers. So here we are given the displacement function s of t as equal to 3t cubed minus 9t squared plus 24t plus 5, where t is greater than or equal to 0. When is object at rest? It is at rest when the velocity, which is derivative of displacement, is equal to 0, right? So let's find the velocity function, which will be 3 times 3, which is 27. Okay, so which is 3 times 3, which is 9, t squared. And then we have minus 18t plus 24, correct? That's the derivative. Now, we need to equate this to 0 for the object to be at rest. So that means 9t squared minus 18t plus 24 should be equal to 0. You can simplify this a bit. You can write this as, you can take 3 common, right? So we get 3t squared minus 3 times 6 is 18 and 3 times 8 is 24. Now t will be what? Minus b, which is 6, plus minus square root of b squared, which is 36, minus 4 times 3 times 8, right? Over 2 times 3, which is 6, right? Okay, so that is what we need to calculate, which is, let's calculate this answer. Within square root, we have 36 minus 4 times 3 times 8, which is okay, so which is a negative quantity. So this is not real, right? So okay. So in this particular case, clearly 8 times 4 is 32, and that is negative, right? So it is not real. So the object is never at rest. So we can conclude from here that never at rest. Now that also means there is no turning point. Since if there was a turning point, it will come to momentarily at rest. Is that clear to you? Right? So first, when is the object at rest? The answer is never. Okay, now part B is determine the velocity after 2 seconds. So we can substitute 2 here in our velocity function. We get 9 times 2 square minus 18 times 2 plus 24, correct? So let's calculate this value. So we have 9 times 2 square is 4 minus 36 plus 24, which is equal to 24. So velocity at 2 is 24. The units are meters per second. Okay. Now let's answer, this is part B, let's answer part C, which is the object moving towards or away from the starting point at t equals to 2? Well, we have seen that velocity is positive and there is no turning point. It is never negative, right? It's always positive. So it is always moving away, correct? That is, you can see from these two that moving away. At t equals to 2. But here is a very standard way of finding when is object moving away or moving towards. So what we do here is that we need to find the product of velocity and displacement. Now that decides whether the object is moving away or it is moving towards. If this is greater than 0, then it is away, right? If this is less than 0, then it is towards. Now let's figure out what is S of 2 equals to. So let's calculate S of 2. So S of 2 will be 3, 2 cube minus 9, 2 square, 2 square plus 24 times 2 plus 5. Correct? Let's figure this out. So I'll put here values, which is 3 times 8 minus 9 times 4 plus 24 times 2 plus 5 equals to 41, right? So this is positive, right? Now in our case, we see that both are positive, right? So both are positive. So we have 24 times 41, right? Which is definitely greater than 0 and therefore moving away. So generally, we use this product to figure out whether the object is moving away or towards, right? And of course, if velocity is 0, it will be 0. That means stationary. So that is how you need to figure out. In our case, we saw that there is no turning point. Velocity is positive, and therefore, it has to be moving away, right? So the answer here is moving away. So with that, we come to an end of our test paper. I hope you understand and appreciate our efforts, and I hope that helps you in understanding this particular unit. It is extremely important unit. And with this selection of 7 questions, you should get fairly good practice of the test. Feel free to write your comments, share your views, and if you really like and subscribe to my videos, that'd be great. Thanks for watching and all the best.